Welcome to episode 3 of the Python Basics series. In this episode, we're going to be going over comparison operators, if, elif, and else statements, and logical operators, which will allow our code to do different things based on specific conditions, and allow it to manage decisions as well. So right now we know how to print out text to the user and save pieces of information inside variables. But right now when we run our code, it runs the exact same code every single time. However, there are cases when, based on whether a specific condition is true or false, we have to run different pieces of code or do different things. A real-world example of having to manage a decision would be whether you should continue driving at an intersection. You wouldn't want to go right away because you have to look at the traffic light and see what color it is. If it's green, then you can go, but if it's red, then you have to stop. If this decision-making process wasn't there, then we'd either have to go every single time or stop every single time, which doesn't actually work in practice. And this shows how we need control flow in programming languages like Python in order to control what the code does based on whether a specific condition is true or not. So before we actually make a decision, we have to ask Python a question. And so in order to do that, we can make use of comparison operators that we could use to convert a question into a yes or no answer or a Boolean value. And from there, we can check if that value is true, and if so, we can run specific code. Or if it's false, we can also run other code. So the various comparison operators include double equals, which stands for equal to. Notice how this is different from the single equals that we used to assign a value to a variable last time. There's also exclamation mark equal sign, which is not equal to, a less than sign, which is less than, and then a greater than sign, which is greater than, and then those same two, less than or greater than, with an equal sign at the end to check if they're either less than or greater than or equal to a specific number. So as an example, let's use the is equal to comparison operator to check if my username is Dr. Arman right here. So we can create a new variable, is Dr. Arman, and then that'll check for whether the username is equal to. Notice we have to put double equals because single equals would just refer to assigning a value to a variable, not actually checking for equality. And then we can put Dr. Arman on the other side to check for equality between these two values. So now if we were to print out this value, you can see when we run the code, it says true because this username value is equal to Dr. Arman. However, if I were to change it to something else, then you can see it returns false because the username has changed. Now let's try out a numerical comparison. So let's say that we have a game that requires 75 points in order to win. So we can create a new variable called game1, and then we can make it check for if the points variable here is at least 75 or greater than or equal to 75. So we can say points and then a greater than sign and then equal sign to check for either one of points greater than 75 or points equal to 75, and then we can put 75 on the other side. And now we can print out this Boolean value. And you can see that it prints out false because 50 is not greater than or equal to 75. But if I were to change my points to 75, then it would return true because 75 and 75 are equal, or even 80 would work because 80 is greater than 75. So now we know how to create conditions or questions and resolve them to a Boolean value, but how do we conditionally run code based on those Boolean values? In order to do this, we can use the if, elif, and else statements, which help us run different code depending on those conditions that we mentioned earlier. So the syntax is looking like this. Firstly, starting with the if statement. So there's an if in lowercase, and then the first condition, and then a colon to signify that the code to run if condition 1 is true will come next. And the code to run if condition 1 is true is also indented to clearly show that this is a specific branch of the code. And then next, after the if statement, we have elif statements. So these elif statements, they only run if condition 1 is false, and they check if other conditions potentially might be true. So this elif condition 2 checks if condition 1 is false, but condition 2 is true. And then you can keep adding additional elif statements, as many as you need to solve your problem. And then finally, there's the else statement, which runs the code after it only if all of the conditions tested are false. So else is just like a fallback just in case all the conditions fail. So in this if, elif, and else group of statements here, only the if statement is actually required. The else statement isn't really required, and the elif statements are optional as well. So if the if statement is all you need to solve the problem, then that's good. Otherwise, the elif and else statements are also there to help you. So let's go back to that traffic light scenario that we mentioned in the beginning of the video. So we talked about how depending on the color of the traffic light, so if it's green, then we're allowed to go through, but if it's red, then we cannot. And so firstly, let's start by checking if the traffic light color is green to see if we can pass. So firstly, we need an if statement for that to get started. And then after the lowercase if in the space, we have to put our first condition. So in this case, we're checking if the traffic light color is equal to green. So our first condition can be traffic light color equals green. And then we can do a colon after it. And then notice how when we press enter, you can see the next line is actually indented. This is to show that the code that we put inside of this if statement is actually considered a block of code, a separate block of code from the main body right here outside of it. And so this is meant to show that this block of code right here is a specific branch of the code. And it shows how our code actually branches out so that it doesn't do the same thing every single time. It checks for a specific condition and does something based off of that. So this indentation kind of helps to divide the code and show how it branches out into different areas. So in this case, because the traffic light is green, we want to advise the user to go. So we can just use a print statement here saying go, keep on driving. And then if we run our code now, you can see it says go, keep on driving because the traffic light color is currently green. So we're allowed to keep going. However, what about the logic for when the traffic light color is red? As you can see, it prints nothing because we haven't implemented that yet. And so in order to implement a red traffic light, its functionality, we can add another condition to this block of if statements, this group of if statements. I'm making use of the elif keyword. It's all in lowercase again, and then we can put another condition after it. So in this case, we're checking if the traffic light color is red. So we can just copy and paste this condition from up here and replace green with red. And then in this case, we can print stop, wait for the light to turn green. And then if we run the project again now, you can see it's detected that the traffic light's red and it's given us advice that matches that. However, there are also yellow traffic lights, so we have to code functionality for that too. So in order to do that, we can add another elif to check for another condition and then remove this indentation. And then we can check if the traffic light color is equal to yellow this time. And then if so, we can print slow down and prepare to stop. And now if we run the Python code and change the traffic light color to yellow, you can see this advice for a yellow traffic light is being printed out to us. However, let's say that the traffic light color given to us is not green, red, or yellow. Maybe it's blue. And in this case, we don't really know what to do because we aren't familiar with the blue traffic light. So we can just make an else block now to check if the traffic light color is not green, red, or yellow, so that we can let the user know that this isn't a valid traffic light color. So we can type in else and then another colon, press enter, and it'll automatically indent it for us. And then from there, we can print out that's not a valid traffic light color. And now if we were to run the code, you can see this is what's printed out. So as I mentioned before, the indentation is important because it signifies a branch inside the code. And so if we were to get rid of this indentation, you can see red lines appear under each of the print keywords here and these other keywords as well. And if we were to run the code, you can see there's an indentation error because we need an indented block to show that this code branches out into different areas and does different things depending on this condition, these conditions right here. So the final concept we'll be going over today is logical operators. These can be used to manipulate questions or change them, or combine questions into a single question which has multiple parts to it. So the three logical operators available in Python are AND, which checks if both conditions are true, or which checks if one condition out of the two provided are true, or not, which checks if the condition is not true. Or in other words, it flips the question around to provide the opposite result. So let's say we have an arcade game which you can win by scoring a certain amount of points without using power-ups. And so we have two variables, one for points and one for whether power-ups were used or not. And so in order to test if the points exceeds a certain value, so let's say 75, points is greater than or equal to 75, or and in this case, because we want to check if there weren't any power-ups used as well. And so what we could do is we could create an if statement, and then we can check if the points is greater than or equal to 75. And then we also want to check whether power-ups were not used. And so then we could write and to check if both conditions are true. And then we could use power-ups used as the condition. Because power-ups used is a Boolean value, so we don't need to check if it's equal to true already, because if it's equal to true, then this Boolean value would also resolve to true. So this equals equals true is actually redundant. And so if these two conditions are true, we can print out U1. And now if we run the Python file, you can see we exceeded the number of points, but we used power-ups. So that means we shouldn't have won, but it prints out you won. This is because it checks for whether power-ups were used, and we want to check if power-ups were not used. So we can use the not keyword before it to check if power-ups used was equal to false. So if we run the Python file, you can see it now doesn't print out anything because we used power-ups. But if we were to use false here, say we didn't have any power-ups that we used, then it'll print out you won. But if we have less points, then we didn't win because we didn't reach the minimum number of points. However, if we wanted to check if just one of these two conditions were true, then we could use or instead of and. So that if we either didn't use any power-ups or we reached this 75 points, then we will win. And so now if we run it, you can see that we won because even though we didn't reach a number of points, we still didn't use power-ups, which means that we won the game. Finally, we'll briefly go over nested if elif else statements. And these allow sub-branches of code within branches. Or in other words, after checking for a condition, you can check for even more conditions inside of that code block. So let's go back to this traffic light color example. And let's say there's another variable for whether a police officer is present. And then we can set that equal to true or false. And so if the police officer's present, then obviously we just want to listen to them. We can ignore the traffic light. So we can say if police officer present, then we can print out listen to the police officer. And then otherwise, if that's not the case, then we can check the traffic light. And you can see how we indented this block of if, elif, else statements one further down so that we can recognize these as sub-branches of this branch that's created by this else block right here. So if we run the code, you can see the police officer is present, so it just says listen to them. Even if we change the traffic light color, you can see nothing changes. But if the police officer isn't there, then the program goes by the rules are provided by the traffic light color. So to cap off this third episode of the series, let's try out a challenge that goes over the concepts that we've learned. So try to create a project that checks for a user's age to see whether they can enter a bar or not. And also let them know the restrictions that are being put on them based on their age. So if they're 21 years old, at least, then welcome them in with a friendly manner. However, if they're between 18 or 20, invite them in, but tell them that they cannot have any drinks. And otherwise, if they're below 18, do not let them in. This concludes episode 3. Make sure to like and subscribe if you enjoyed the video, and thank you very much for watching. Make sure to look out for episode 4 coming tomorrow.